Hello everyone, welcome to part 2 of the college algebra exam review. Let's get started. Number 21 says, determine the slope of each of the following, show all work. Alright, so if we remember, let's just take a look at some things that we know about slope. So we know a line formula is y equals mx plus b, correct? And in this y equals mx plus b, we know that m is our slope. And m can be calculated multiple ways. If you have a graph, it can be calculated by using rise over run, or vertical change over horizontal change. If you're given 2 points, you can calculate it by doing the change in the y's over the change in the x's, or y2 minus y1 over x2 minus x1. And then if you're given an equation, you can move stuff around to get this form right here. And once you get that form right there, your slope is just the m. All right, so let's get started with this problem. It says, a line that passes through the points -4, 1, and 2, -2. So this is this one right here. So easy, we're just gonna go ahead and use those 2 points. Okay, so if we have our points -4, 1, and 2, -2, and we plot into this right here, it will look something like I'll call these our x2, y2, and I'll call these our x1, y1. So if we do y2, that's -2, minus our y1, which is 1, all over our x2, minus our -4. That'll give us -3 on top, and a +6 on the bottom, which reduces down to -1/2. So our slope for this first one is m equals -1/2. All right, and this next one is similar. You're also given 2 points. So our 2 points are 3/4, 2, and -3, 17. And I'm gonna go ahead and treat them the same way. Our x1, y1 are on the left side, and our x2, y2 are on the right side. So if we do our y2, that'll be our 17, minus our 2, all over our -3, minus this 3/4. And we are left with 15 on top, and the -3 minus 3/4 will give you a -3 and 3/4, which will just be a -15, -15 over 4. So then, essentially this is a correct answer, but we can make it look a little nicer. If you remember the idea that if you were dividing by a number, you're essentially multiplying by its reciprocal. So if you were dividing by -15 over 4, that is the same as multiplying by -4 over 15, which now you would see that these 15s will cancel, and you're left with -4. So our slope for part B is m equals -4. All right, then C says a vertical line. So if we have a vertical line on a graph, something like this, right? Our graph yx, and we have some vertical line here. If you remember, the formula for a vertical line is x equals some number, right? Let's call this 3 in this case. So for this problem, this example, x equals 3. Now, if you look at this correctly, or if you look at this, say we pick a point here. So this is our 0, and we'll call this 2. So that means our points are 3, 0, and 3, positive 2. Now, if we were to use our point formula that we used up here, we'd do our, let's call this x2, y2, and we'll call this our x1, y1. So if we did, our m is y2 minus y1 over x2 minus x1, and we plugged all these points in, you'd end up with 2 minus 0 over 3 minus 3, which gets you 2 over 0. You cannot have this, which means that this is undefined. Also, just a rule of thumb, if you were to look at this, there's rise, but there's no run, right? So for rise over run, we have a rise of 2 over a run of nothing. Same thing we got over here. Again, we can't have that 0 underneath, which means that this slope is undefined. So for this one, we'll just say m equals undefined. All right, now I'm going to use the same graph to pick a line that's horizontal. So we'll do this line right here, right? And we'll pick a point here, and we'll pick a point here. And let's say that the graph of this line is a y equals number, and we'll call this -3. So this is y equals -3. So our point here is 0, -3, and our point here is 3, -3, correct? All right, so now we have two options. We can use either rise or run, or this m equals y2 minus y1. So let's try both of them. We'll call this x1, y1, and we'll call this x2, y2. So if we did m is y2 minus y1 over x2 minus x1, and we plugged in our points, -3 minus a -3 all over 3 minus 0, you would end up with 0 over 3, which is what? 0. This, unlike the other one, can be done. You can divide 0 by any number, and you just get 0. So this is saying that our slope is 0. So let's say we did rise over run here, right? If we did rise over run, our rise is 0, and our run is 3. So same thing, you get a slope of nothing. So m is 0 for D. Alrighty, so now we'll go to E. E is y equals 2/3 x minus 5. So this y equals 2/3 x minus 5 is in the form y equals mx plus b. And from up here, we said that when it is in an equation, you get into the form y equals mx plus b, and it's just our m. So these y's match, these x's match, and we have some b there. So that means that is our m. So m is 2/3. All right, and for this last one, this one looks a little different, right? But it's also just an equation of a line. 3x plus 4y equals 4. So for this one, you can actually manipulate it. Let me double check that, make sure that that is the right numbers. 3x plus 4y equals 4. Okay. You can just manipulate these numbers to get y equals mx plus b. So essentially for this one, we want y by itself. So let's start moving stuff over and get y by itself. So I'll subtract just 3x over 4y equals -3x plus 4. And see, we're getting closer to this form up here, right? So now the only way to get y by itself at this point would be to divide the entire thing by 4. Every term on the right side by 4 as well. And we'd end up with y is equal to -3/4 x plus 1. So, again, Here's our m, and here's the m we came up with. So that means that for this problem, our m is equal to -3/4. Alrighty, on to the next one. It says, write the equation of a line in slope-intercept form that passes through the point -1, -4, and has a slope of 3. Show all work. So, slope-intercept form is just that same form we've been talking about earlier, because it has a slope and an intercept. That's why it's called slope-intercept form. So, we are given our slope. So we know our m. M is 3. What we don't know is b. But we do know some xy point. -1, -4. So let's plug in everything we know. We know y is -4. We know m is 3. We know x is -1. And we don't know b. But we can find b because we know everything else. So this is -4 equals -3 plus b. We add 3 over. We know b is equal to -1. So now let's plug that all into a nice y equals, we know m was 3, x plus our b, which we decided was -1. So another way that you can write that would be y equals 3x minus 1. Alrighty, so this next one says, given the function defined by fx is x cubed plus 2, determine the average rate of change on the interval -3 to 0. Show all work. So this function, don't know exactly what it looks like, but we do know that we're going to be looking at it. Say we have a graph. We have some function, and we're going to be looking at it from -3 to 0. So we're essentially zooming in just on this part of the graph. I'm trying to figure out what that graph looks like. So again, I don't know what that graph looks like, but we can find some points, right? So we know some point 0, and there's a -1 and a -2 here, right? We know at some point 0 it's going to be something. So if we know f of x is equal to x cubed plus 2, we can plug in our x is 0, so we can find f of 0. So f of 0 would be 0 cubed plus 2. F of 0 equals 2. Same thing with our -3. -3 cubed plus 2 would be, I believe that is, -3 cubed is 25, and a -25 at that, right? So we essentially know 2 points. We know at 0, we're going to be at 2, and at -3, we're going to be up at, or we're going to be down actually, at some -25, right? So now, essentially what we want to find is, again, we don't know what this graph looks like, but we want to find the rate of change between those 2 points. Or we want to find the rate of change of the graph in this interval. So, how can we do that? We have 2 points, and we know that rate of change is essentially equal to m. And what did we say about finding m from 2 points? That's just y2 minus y1 over x2 minus x1. And in this case, that would be f of x2 minus f of x1 over x2 minus x1. These are the exact same thing, just written in slightly different manners. So let's plug in what we know. We know that f of x2 was 2 minus, we know our f of x1 was -25. Over, we know our x2 was our 0 minus our x1 was our negative 3. So then what does that look like? 2 minus a negative 25 will give you a positive 27. 0 minus a negative 3 will give you a positive 3, which means that our average rate of change between those 2 points is 9. So you can just write something like average rate of change equals 9. All right, now on to the next problem. Write an equation of the line in slope-intercept form that passes through the points 2, negative 5, and 7, negative 3. So let's look at this problem. We don't have a slope, but we do have 2 points. And we said earlier that when you have 2 points, you can find m by using this formula, correct? So let's go ahead and find m, just so we can get one part of our equation, right? So we'll call this x1, y1, x2, y2. So y2 we said was negative 3 minus our y1, it's negative 5, all over our x2, which is 7, minus our x1, which is 2. So that'll give us negative 3 plus 5, which is 2, over 7 minus 2, which is 5. So this is our slope. So if our line equation looks y equals mx plus b, we have this, and we have 2 points. So essentially we can pick any one of those points and have xy, which means we'll just have to look for b. So what I mean by that is one of our points was 2, negative 5, right? So one of our xy points was 2, negative 5. So we can plug into our equation. Y is negative 5 plus, not plus, equals our m, which we came up with was 2/5, times our x, which is 2, plus b. So now we just move everything around and get b by itself. So this is negative 5 equals 4 over 5 plus b. If we subtract 4 over 5 over, we will get negative 29 over 5 equals b. So now we have all the parts to make our nice equation, right? So our equation is y equals, we came up with an m of 2/5 x, and we came up with a b of 29 over 5. Or negative 29 over 5. Alrighty, next problem says, write the equation of the line in slope-intercept form that passes through the point negative 7, 3 and is parallel to the line defined by x plus 3y equals 6. So, if you'll remember a few things. If a line is parallel to another line, that means they do not touch. Ever. Right? So, something like a line here and a line here. They're parallel, right? Just like railroad tracks. So what does that say about the slope here and the slope here? They're the same, right? So we know that if they're parallel, slopes will be equal. So knowing that much, and we know a line, right? We know one of our lines is x plus 3y equals 6. And let's manipulate that to make it look nice, to make it into the form of y equals mx plus b, so we can see what that slope is. So I'm going to move this x over, try to get the y by itself, negative x plus 6, and I divide everything by 3. So we have y equals negative 1/3 x plus 2. So we know the slope is negative 1/3. Because they're parallel, and because these two lines are parallel, we know that the slope of our line is also negative 1/3. And then we also know this point right here. Right? And this is just kind of like how number 22 was, where we are given a slope and we are given a point. y equals mx plus b. We know a y from our point xy is, sorry, I keep forgetting, -7 plus +3. Okay, so if we plug into here, we know our y is 3. Oh. We know our m was 1/3. We know our x is -7. And we know, or we don't know b, and that's what we're looking for. So, once we simplify this, we will subtract the 7/3 over, and we will be left with b equals +2/3. So now we have all the components to write a nice slope-intercept line. So we know our slope is that -1/3 we came up with, right? Because it's parallel to that line that we were given. And then we also found our slope-intercept, or our intercept, sorry, was 2/3. So now our slope-intercept form for this equation, or for this line, looks like this. Y equals -1/3 x plus 2/3. All right, 26 says, write the equation of the line in slope-intercept form that passes through the point -8, -4, and is perpendicular to the line defined by 6y minus x equals 18. Show all work. So this one's slightly different because we're not talking about parallel lines. We're talking about perpendicular lines. So now we have a line that looks something like this, right? And we know that it's perpendicular because there's a right angle between the two, right? Now, what do you notice about these slopes, right? The slope for this line is positive. The slope for this line is negative. And then we also know that the slope for this line looks slightly steeper than the slope for this line, which is a little hard to see off the top of just from a sketch. But essentially, when you have two perpendicular lines, they do cross at one point. Slopes will be opposite reciprocals of each other. So they won't be equal, but they do still have a relationship. They will be opposite reciprocals of each other. So what that means is that, say our slope for our blue line is m equals 1/2, right? That means that our slope for our second line would be the opposite reciprocal of our line. So, something like that. And this is just an example, right? So, let's look at what we were given. We're given a line 6y minus x equals 18. We can go ahead and put that into y equals mx plus b form by moving stuff around. So I'll go ahead and move this x and divide everything by 6. And that will give us y equals 1/6 x plus 3. Okay, so this is our slope for our line perpendicular. So if we want the slope for our line, it will be the opposite. So it'll be a negative because we're given a positive here, and it'll be the reciprocal of it. So just switch the numerator and the denominator. So that means the slope for our line is -6, 1. So we're also given a point, -8, -4, and from this point, we should be able to solve. We have y equals mx plus b, and we're given a y. I need to write these points down. -8, -4. okay? And so we know y is -4. We know our m we came up with is -6. And you can get rid of that one because it's just over 1, right? X is -8 and plus b, and that's what we're looking for. So we have -4 equals 48 plus b minus 48 minus 48. B is equal to -52. So now we have every part to write our nice equation. So we are going to write y equals, we decided our m was -6, x, and we came up with our b as -52. Alrighty, so now we're gonna take a little turn and we're gonna talk about transformations of graphs. So if we have a graph y equals x squared, and we are going to transform it to become f of x equals x minus 2 squared plus 3, we need to see what transformations are applied, right? So first of all, I notice this change here, and I notice this change here compared to the y equals x. So if you remember, everything that happens to the x directly happens horizontally. So this is a horizontal transformation. And anything that happens to the entire function, kind of like how this 3 is a vertical transformation. Now to figure out what those transformations are. So we are essentially adding 2 to our x, or we are shifting our x in the right direction 2 units. So we have a horizontal shift of 2, and then for our vertical shift, we are moving 3 units. And we're moving +3 units and +2 units. So let's see what that will look like if we graph it. Alrighty, so from the last page, we were talking about this function, y equals x squared, and we talked about this transformation of f of x right here. So we decided that the 2 here was a horizontal shift of 2, and this 3 here was a vertical shift of 3. Now, what does that mean in terms of graphing? So horizontal shift of +2 means that we are moving this graph to the right, right? If it was a horizontal shift of -2, we'd be moving the graph left. Same thing with the vertical shift. Since it is a +3, we are moving up. If it was a -3, we'd be moving down. So now let's graph this. I'm going to take this point on the graph, and I'm going to transform it essentially. Let me pick a different color. We'll do black. So this point right here, I'm going to shift it over 2 to the right, so somewhere here. And then I'm going to shift it up 3. So something like that. So our new graph will actually have a point here. So I'm going to go ahead and shift a few more points just so we can see. I'm going to shift this point here, right 2, and up 3. So that means our new point is right here. All right, and I'm going to shift just one more point. I'm going to shift this point here, and I'm going to shift it right 2 and up 3 units. So our new point is right here. So now if we were to graph this, we'd have a graph that looks roughly like that. Could have been drawn better, but roughly this is the idea, right? We still have a quadratic function. It's still pointing upwards because there were no reflections, but it's just shifted right and up. All right, the next problem says a speeding ticket is $100 plus $5 for every 1 mile per hour over the speed limit. A says, write a linear function to model the cost Sx in dollars of a speeding ticket for an individual traveling X miles per hour over the speed limit. And then B says to evaluate S of 15 and interpret the meaning in the context of this problem. So we need to come up with an equation where S of X is the total cost, and this X here is the miles per hour. So what do we know? We know that a speeding ticket is $100, plus it's $5 for every mile per hour we go over the speed limit. So we know essentially that $100 is a fixed cost. So that will be added to our rate regardless. And we know some rate. $5 for every mile per hour over. So these are both dollars, which means that if we have dollars and we add dollars, we should get a total cost, right? So our S of X will look something like S of X is our $5 per hour, $5 per mile per hour, times the miles per hour that we go over, plus the fixed $100 that we will always have. So that's our equation there. So now in order to evaluate S of 15, we would just essentially plug in this 15 anywhere we see an X in this function. So S of 15 would be 5 times the 15 plus 100, which is, if we do some quick math, we will get 5 times 15 plus 100, 175. And we said that S of X is our dollars. So this is $175. So what does that mean? That means, and I'll write this down, this means that when you go 15 miles per hour over the speed limit, your speeding ticket will be $175. So say the speed limit's, I don't know, 70 miles per hour. If you go 85 miles per hour and you get a speeding ticket for it, it'll be $175 of a speeding ticket. Alrighty, let's move on to the next problem. So it says the data given in the table represent the age and systolic blood pressure for 12 randomly selected individuals. So this is essentially an XY graph, or a YX graph, or you can call it an AS graph, but it's essentially two variables, one that depends on the other. And here it seems that your blood pressure will depend on how old you are. All right, so now let's look at what this question is asking. So I brought our table from the other page, and I've put it right here for us to keep looking at. So this is using the regression features on your calculator. Find the least squares regression line. Round A to 3 decimal places, and B to the nearest whole number. And then B says, determine the correlation coefficient of 4 decimal places and indicate if the regression line is or is not a good fit to the data. And C says, use the model from part A to approximate the systolic blood pressure for a 55-year-old. Round to the nearest whole number. So let's start by, we are going to have to plug these numbers into our calculator. So let's look at this. In our calculator, I'm going to actually write down the steps for how to do this in our calculator. In our calculator, in order to get, oh, what is going on? Okay. In order to get, I'm going to make this tiny so we can zoom in on it. Oh, what just happened? No, let's put it right there. and we're going to zoom in right here. So in our calculator, it's just a step-by-step how to plug it in. So there's a button on your calculator that says Stat. We will press that button, and we will be in the Edit tab. At the top, there are 3 tabs: Edit, Calc, and Tests. We will be under the Edit tab, and under this Edit tab, we will click a 1. So now you should be taken to a screen that looks somewhat like, I'm going to try to sketch this as best as I can. Okay, so we should be looking at something that looks like this in our calculator. So essentially what this is, sorry, I just realized y'all couldn't see the top. Essentially what this is it's asking for your X values, your Y values, and then it's going to give you some function based on those X and Y values. So we know our X values here, right? And we know our Y values here. So we will plug in our Y values into this chunk, and we will plug in our X values into this chunk. And that little black box just signifies that that's what you're editing. So this is our edit box. Oh, I did not want to highlight that. Our black box is just where we're editing. So let's go ahead and plug in these points. Okay, now that we've plugged in all our points, you're going to go back and click your Stat button again. So let me just write this down. So you will click Stat one more time. But this time, we're not going to be in Edit. We're going to be in Calc. Right? And we are going to go down to where it says linreg, that's it, capital R, capital L, linreg AX plus B. And that is actually number 4. So you can click number 4, and it'll take you there. And then we will click Enter. So, Enter. And once you click Enter, you should be looking at something that looks like this. Okay, so this is what should be on your calculator screen right now. So for this problem, we are asked to write our equation using A and B, and we need to round A to 3 decimal places and B to the nearest whole number. So our equation will actually look something like y equals 0.511x plus 104, because we rounded that to 3 decimal places and the 104 to a whole number. So this is our equation of this line. All right, now the next one says determine the correlation coefficient. So this is where it gets a little interesting. Some of you all may have r squared, other values under this A and B. If you do not, what you need to do in your calculator is you need to go to the second function. So click the second button and press the 0, which is also the catalog. And it should take you to a list that starts with ABS, and you'll scroll all the way, it's in alphabetical order, so you need to scroll to the D's to where it will say something like diagnostic off, diagnostic on. And there's other things above it and other things below it. You need to hover over diagnostic on to turn your diagnostics on for finding basically your r and r squared. So I'm going to go ahead and click on mine, and it's going to show up in your regular calculator screen, and then you're just going to press Enter. All right, and then it'll say something like done. And from there, you should be fine. So now let's go back and do our linreg again. So basically, I went back and just redid this whole step right here. I redid this step here. And now I get an r and an r squared on top of my A and B that I had originally gotten. So And now I got an r that is equal to 0.961348959, 9549. And I also got an r squared of 0.924191813. So these are two new values that you should have showing on your screen. And if you can't get it figured out, I would recommend either coming to the MLSC, getting someone to help you with it, or asking your professor about it. But essentially, once you have those two values, you're able to answer B. It says determine the correlation coefficient. So our correlation coefficient is our R. So this is just our R. And we need to round it to 4 decimal places. So it'll be something like 0.9613 is our R. Okay. And from that, what does that mean? So the closer to 1, the better a fit it is to your line. So this is really close to 1. So this means that our line is a good fit. Awesome. And now we have our model from part A, which I'll rewrite right here. Y is equal to 0.511x plus 104. And we are trying to figure out what will our blood pressure be if we are 55 years old. So we need to go back and think about what we originally talked about were our X and Y. So we originally stated that our X was our age and our Y was our systolic blood pressure. So we are looking for systolic blood pressure. So we're looking for Y in this case. And we know X is 55. So this is X. And we want to know Y. So Y is a question mark and X is 55. So we'll just plug that into our equation. Y is equal to 511 times 55 plus our 104. And you'll get something along the lines of 132.105. And you want to round it to the nearest whole number. So our nearest whole number is 132. So this means that according to the model, the systolic blood pressure for a 55-year-old should be 132. Let me write that in black, actually. There we go. So all that means is that a 55-year-old, so it's some data that fits right here, it should be roughly 132, which seems like it makes sense for our graph, or for our function. Alrighty, now let's look at number 30. It says identify the following basic functions from their graphs. Alrighty, so this first graph we actually can recognize from our problem on the previous page. This is simply a quadratic function. Right? There's no shifts, no nothing. It's just a y equals x squared function. This function here is our y equals x cubed function. And that's just what it looks like. It increases and has this little like bloop. This function right here is our 1 over x function. And all this means is that our y's get bigger, our x gets smaller, and vice versa. As our x gets smaller, our y's get bigger. So it's an inverse of itself. Now this function right here, this is an interesting function. So we notice that we don't have any negative x's or negative y's. We only have positive x's and positive y's. So this is actually our function f of x is the square root of x. Because if you think about it, you can't have a negative x under their radical, right? And from that, you will never get a negative y. All right, now this function. This function's interesting. So if you notice, these two functions look very, very similar. Right, so this function, y is x, I'm gonna rewrite this, y equals x cubed, that's that function. This one looks like it was just turned on its side. So essentially, it looks like our x and y's switch spots. So the way to do that actually is you would want to find the inverse of this function. So we'll solve x in terms of y. So we'll have x is equal to y to the 1/3. And now we want this function to actually be a y equals x function. So now we'll just change this to a new y equals a new x to the 1/3. So essentially this is this graph, which we can also write as x is the cube root, or y is the cube root of x. All right, now this last function, this one's similar to the square root function. So we notice that there are no negative y values. You can have positive x and positive y, or positive x and negative x, but you will never have any negative y values. That is actually the function of the absolute value of x, right? Because if you had a -2 here, you'd get a +2. If you had a +2, you also get a +2. If you have a +5, you'll get a +5. If you have -5, you'll get a +5. So f of x is the absolute value of x. And these are just functions to be vaguely familiar with. All right, last problem is 31. Given the basic function y equals the absolute value of x, use the transformations to the graph. List the transformations in order to be applied. So this is essentially this function, right? And we're trying to shift it and also figure out what the transformations are. So we notice that there's this +3 in here, and there's a minus outside. So this means, like how we talked about earlier, this is happening directly to the x. So this is a horizontal transformation. And similar to the last problem, this is a horizontal shift. Unlike the previous problem, though, this is a horizontal shift -3 units, or 3 units left. And the reason for that is because typically this is written as x minus our h, or our horizontal shift. So if we have x minus h is x plus 3, we know that if we get rid of these x's, our opposite horizontal shift is +3, which means our horizontal shift is a -3. Alrighty, so we have a horizontal shift of -3 units, or 3 units left. Alright, so now let's talk about what's happening in the green part. So we know that's a negative, right? And it's a negative happening to the entire function. So it's actually a reflection across the x-axis. So you're going to be changing the y values from positive to negative, and I'll show that here. If you have all your y values, right, we talked about this problem earlier, all our y values were positive, but if we plop that negative in front of it, now all our y values will be negative, which means there was some sort of reflection across this line right here, which happens to be our x-axis. So all that means here is this was a reflection about the x-axis. So that's our second transformation. Reflection about the x-axis. Alrighty, so that is that for this review, this part 2 of our review. Like and follow to stay tuned for part 3, and good luck on your exam.